So, hello and welcome to this talk. It's really a pleasure to be here at the Bosch ConnectedWorld 2026. I would like to give a talk from the perspective of a machine builder. Now, title is From Virtual to Autonomous, System Digital Twins, Bridging the Gap Between Engineering and Operations. And one focus point will be how the engineering twin actually empowers operations. My name is Andreas Braun, Head of Engineering at BMG or Bosch Manufacturing Solutions. Now, obviously, industrial AI is a very hot topic. We've seen it over the last 1.5 days, and the use of AI to optimize industrial processes is widely seen as transformative. Citations that I've brought with me here include game changer, redefine, transform, so there is no lack of big words. And this talk is about how we as a special machinery builder are tapping into this obvious potential. So what's our approach? We, as always, come from the customer perspective, where we see certain essential expectations to production systems. And there are no surprises here. During the realization phase of production systems, customers expect lean concepts, robustly designed systems, and fast delivery and ramp up. During the operations phase, that's on the lower left-hand side, customers expect reliable performance. They expect increasingly self-adjusting machinery that does not require the attention of experts and machinery that is ready for retrofits and services. So how do we as Bosch Manufacturing Solutions address and fulfill these expectations? We harness our deep systems and process know-how that I put in the center here to build digital twins using semantic data. And let's start in the upper semicircle here with the engineering digital twin. In our world, the engineering digital twin is created in our data backbone and is essentially a set of digital models. And we use these models then to carry out early simulations, digital feasibility studies, but also to digitally validate our engineering solutions before the equipment is built physically. And we will see examples of this in a minute. In operations, we create a digital twin of production systems as they are running. And once again, we rely on our systems and process understanding to provide the right semantic operational data from the depth of the machinery. To do that, we have developed the so-called BMG Intelligent Production Suite, where we provide tools for connectivity and semantics, operational transparency, operational continuity, which basically boils down to maintenance, support and excellent maintenance, but also for closed loop control and agentic optimization with a clear vision of increasingly autonomous machinery in mind. And this way, we are closing the circle and underpin our value proposition: lean, reliable, adaptive. Now, who are we to make such claims? Let me quickly introduce us. For those of you who do not know Bosch Manufacturing Solutions, we are a global industrialization partner and turnkey special machinery provider. We have more than 30 years of experience under our belt and have delivered more than 5,000 assembly and testing systems and many more smaller and services projects. We can custom tailor our automation level to you, and we are all digital, from planning over engineering to the digital solutions we provide to you to run and operate our machinery excellently. We are close to you with more than 17 locations around the globe. We have a vast full liner portfolio and more than 1,800 smart people working for us. Our turnover has exceeded the 500 million euro mark as of 2025. Now let's have some fun, and I will go deeper now in the two semicircles, engineering and operations. Let's first delve deeper into engineering and the engineering digital twin. I spoke about the digital models in our world. Indeed, the engineering digital twin is based on an set of digital models, and this slide approximately shows the current scope that we have as Bosch Manufacturing Solutions. We like to distinguish between models on production system level and models that go deeper on the level of each machinery. And on line or production system level, our models include things like material flows, so how the material flows through the value stream, operators, how many do I need, what kind of pathways would they choose, and similar also for the vehicles that move around in a production system. On machine level, obviously, we go deeper. It makes a lot of sense to talk about 3D geometry and geometric models for machinery. We also covered kinematics, we cover communication of the machine also with the plant environment and many more aspects, including, last but not least, also physical models of the manufacturing or some of the manufacturing processes that we use in our machinery. So how do we make use of these models? And I'm going to show you 3 kinds of simulations that we do on the basis of those models. The first simulation is what we call the value stream simulation. It's happening very early in the process. It's happening before there is even a detailed design available. What are we doing? We are running long-term simulations equivalent to months and sometimes even years of productions. We are checking the line performance very obviously, things like output, throughput time. We are looking at the investment and investment-related items like AMRs, AGVs, workpiece carriers, and minimize them. And we are also checking inter-machine dependencies as you may have them, for instance, time constraints between certain processes. Think of gluing that would harden out. So in doing so, we get a lot of valuable results very early on. Our concepts are validated and robust. We have a lean footprint. We reduce investments. Indeed, we see up to 25% less workpiece carriers in such production systems based on these simulations. And we have laid the foundation, the basis for fast commissioning and ramp up later on. The second simulation is virtual commissioning, and this is happening later. At this point, we have a design ready, we have the PLC software ready, and it's happening on machine level. So here we are really looking into individual machines. What are we doing? We strive to have the software ready, and we run the software against or together with a model of our machinery. And here we are checking much more details inside the machine. We can check the full kinematics, including subsystems like robots. We check special modes like calibration or automated changeovers. And we can put exceptional situations into the game. We can, in the models, in the virtual simulations, introduce wrong types into the machine and there stress test the machinery before it's even built. And we're also checking the communications to the plant environment. And this capability truly has been a game changer for us over the past years. We have, as a result, a fully tested PLC software ready with a high degree of maturity. We have additional robustness built in because we have stress tested the machinery. We see a dramatic reduction in failure costs in commissioning and ramp-up phase, and we shorten the commissioning time by up to 2 months. Last but not least, we are ready for further lifecycle optimizations with a minimum amount of downtime and low risks. As a third simulation, I would like to introduce process modeling. This is now happening deep inside the machine, where machine and product meet, where the process is happening, and think about laser processes at this point. Think about laser machining. And even before the equipment is built, we can rely on physical models of such manufacturing processes that we have built. It's really physics and not empirics, and these models can then be tuned to a specific setup with a minimum amount of data. So you don't need to run extensive experiments. Really, a minimum amount of data is sufficient. Up to 70% less parts is a KPI that we put on these slides. And in this manner, we can validate the process early on and determine an optimum operating window in terms of process parameters early on. Results in fewer trials, dramatically reduced sample costs with up to 70% less test parts. We have enhanced operational robustness built in. And again, we make yet another contribution to the all-important fast commissioning and ramp up here from the process side. What's more in engineering? Yes, we are also using agentic and generative AI in engineering to generate code automatically. And we are doing this, and this is the fun part here, or the powerful part. We are doing this on input that is already available in engineering. For instance, sequence diagrams that we already have. We are making sure that the AI is trained on our coding standards, and our approach also integrates well with the existing engineering environment that we are using. What we're getting a dramatic reduction of programming work, of repetitive error-prone tasks, of coding or encoding, we see a substantially higher degree of software standardization, and we speed up software development by up to 50%, so really significant as well. Now, let's go into the lower part, into the lower semicircle operations. And I would like to speak about operations and the operational digital twin. And as we will see, industrial AI in operations is based on two things. It's based on the right semantic operational data, but it's also based on harnessing the existing engineering twins, the models I have just talked about. And to accomplish this, BMG has set up the so-called Intelligent Production Suite. Here, semantic data from our machines is processed to support excellent operations. And this modular solution set comes in three baskets. In transparency and analytics, on the left-hand side, we provide descriptive analytics to monitor what's going on, including historical data. In operational continuity, we have tools to keep downtime as low as possible, including things like that you would expect predictive maintenance, anomaly detection, and so on and so forth. And lastly, in control and optimization, we provide solutions to enable self-adjusting machinery. And this last basket also supports our push, our vision for increasingly autonomous production systems. On the next slide, I will introduce this with the example module of process parameter optimization that you find somewhere on the right-hand side. Now, what is this example? What I would like to introduce here is one of our laser processes. It's a multi-step laser machining process. Imagine a machining process where after each machining step, you measure and then you check using the existing engineering model. Remember, I showed you that. You use the engineering model to ask yourself, are there maybe optimized parameters available that help us get a better result in the next step? And you go through that cycle a couple of times. So the engineering twin here is really harnessed to achieve optimum results in operations. And in this way, we achieve machinery that runs very much self-reliantly, even calibrates itself when necessary with substantial benefits. Maximum process yield, built-in additional robustness because we have chosen our process window wisely, and there is no need for experts, neither during training nor operations. And this is one example I stressed is how we harness the engineering twin to enable autonomous operations. This slide now gives away more details on our software-defined approach and the flexible and modular BMG software architecture. In the background, highlighted are our BCW showcases that you are very welcome to experience at our booth, including things I have not spoken about, like the BMG automation framework, Nexceed automation, and also our collaboration with NVIDIA and Siemens on our vision of increasingly autonomous manufacturing and special machinery. With that, I would like to come to the summary of my talk today. Firstly, powerful industrial AI needs to harness domain know-how via semantic data. Secondly, operations and engineering converge digitally. The engineering digital twin really is core to self-adjusting machinery. And lastly, please expect much more to come. Self-adjusting processes are just the first step towards increasingly autonomous production systems. Having said this, I would like to close this talk. Thank you for joining me here today. I would be, on behalf of my team, I would be happy to invite you also to our booth. We are at booth number 50. You can experience many of the things I've introduced here in much more detail, and we would be happy to talk to you in much more depth there. Thank you for now, and goodbye. Thanks.